Okay, hello everyone. Welcome to the presentation video for our design project. We are group 3 from LO4 and the title of our project is an instant and smart retail system with cloud analysis. So first, let me introduce some motivation of our project and how we identify the problem. The first problem we made nowadays is the efficient checkout pattern. So have you ever been suffer from the queuing problem? Yes, sure. Everyone, queuing problem nowadays is a very significant issue. But what is the reason for this kind of phenomenon? The reason is the staff has always to wait for the customer to finish their payment. So the manual checkout pattern is inefficient. And also they have to deal with any request from the customer, and that takes a lot of time. So our conclusion is the traditional checkout pattern is not applicable at today. We need to allow more self-service and more payment methods. So the second motivation of our problem is from the increasing labor charge. As we know, payroll cost takes up to about 10% of the total sales. And nowadays, the labor charge has become higher and higher. And also, it has larger customer throughput than the past days. So that means we need we have more demand for labor. So we need to have more labor force, but that will lead to a higher labor cost and it will directly affect profit. So our conclusion is to use more machine to replace expensive manual labor. And next is the demand for analysis of customer interests. As we know, if you can understand your customer better, you can provide them a better quality of service, and also that will in turn result in a higher revenue. But lots of business owners, their lack of analysis tools, and they also do not have a solution provider. Fortunately, we can provide them the customer analysis, and they can do some decision based on the result of our analysis, like the age distribution, the popularity of the product, and so on. So our idea is to build a comprehensive system with self-service checkout, which one has easy checkout process and a clear instruction for the customer. And then it has fastest and secure payment method. The details will be covered in the later part. And also we would like to provide a cloud analysis for customer and the goods. The data will be uploaded to the cloud analysis tools, and then we will visualize the result of our analysis and also result the collecting data in some data form. So yes, and here is the system architecture of our project. We have cloud platform, we had the hardware with LED display and the PCD RFID card, and also Arduino as the main platform. So later I will pass my time to Eric.
So here is Eric. I'm going to share some idea about the solution and function. Our team intend to use the object-oriented approach to build modularized system, and we will have a couple of classes to help us deal with the data. Like customer classes and product classes will help us to deal with the customer and product data, and cut classes will help us handle the consuming event, and peer classes is utility classes. And we build customer behavior detection function. Originally, we used the ultrasonic sensor to detect where the goods being taken by calculating distance change. But unfortunately, it doesn't seems to be stable, and the instability of the detection will result to create further problem to the system. So we changed to use the RFID solution, and it is more stable. We don't want customer to pay for each product one by one, so we create a shopping cart function, and customer can check the product RFID tag to add the product to the shopping cart, and tap the same tag again to remove it. System will display the cart summary, and customer can pay in bulk. We also try to build a dynamic pricing function, and it is to keep recording the customer throughput within certain time interval and adjust the price accordingly. In order to do so, we need an online platform to help us, and we choose ThinkSpeak to be the cloud storage platform. And it does provide basic visualization for the numeric data, but we find that it is not enough. And so we moved the data analysis part to MATLAB, which is a more powerful data analysis and visualization tool. And the reason for us to choose MATLAB is because ThinkSpeak has built-in API to fetch data effectively to MATLAB. So we are going to make good use of this tool. And since RFID play important role in the consuming activity, so we are going to take care of the security issue of it. We replace the default key by custom key. The key has 2 to the power of 48 combination, and it is generally safe to use. Also, for the cloud storage, security issues is going to be taken care, and data stored in private ThinkSpeak channel will protect by the API key. And this is our hardware schematic. Different modules communicate with the Arduino board using different interface. Like OLED will use the I2C interface, RFID module use the SPI interface, and Wi-Fi module use the UART interface. And Michael, we're going to share the outcome.
Now let's see some of the outcome and performance of our system. First, let's see the flowchart of our purchase. First, at the beginning, we will enter into a welcome interface that greet the customer. Once any nearby person is detected, we will switch to an instruction interface to tell the customer what to do. At this stage, if a customer type RFID card is detected, we will simply retrieve his or her name and balance and display, and then switch back to the initial welcome interface. On the other hand, if a product type RFID card is detected, we will enter into a loop where we continuously add product units into it and display the summarized product in the shopping cart. We do this until we detect a customer RFID card again, which is ready to pay for all the products. If the balance within the customer card is insufficient, we will simply display a warning message on the customer that the payment has failed and switch back to the previous shopping cart state. If this balance is indeed sufficient, we will display a payment successful message and deduct the balance from the customer card. Before we switch back to the welcome interface, we record the customer data locally, which will be later uploaded to the cloud platform for further data analysis. And if any category of the product is short of stock, we will light up an LED to warn the shopkeeper to refill. Next, let's see the back-end data storage, analysis, and visualization of our system. As instructed, we use the ThinkSpeak cloud platform to store the data and conduct the mission. As you can see, there are 8 fields in our ThinkSpeak channel. Which records the price and stock of the products and the gender of age of the customer that buy products. One limitation to the ThinkSpeak channel is that its visualization function is only effective for numeric data. This is the reason why we switched to MATLAB to do the further comprehensive data analysis, whether it's within ThinkSpeak, the one within ThinkSpeak, or it's a local MATLAB software. The one built in ThinkSpeak does not have an auto update if we're using a free license. So we leverage a timer class on the local MATLAB software to auto update the data visualization figure that is fed with real-time data. Last, let's see some of the conclusions and highlights of our design. Basically, our system is a system for customer. It's a system with straightforward and flexible payment logic, visual assistance, payment security, and for proprietor, it has real-time data analysis and visualization, and stock monitoring, and it can adjust the price dynamically based on a certain algorithm. Some of the possible improvements that we have thought is that we can embed things, big data visualizations in a web page as a dashboard, but that'll be only feasible when we're equipped with a paid license of ThinkSpeed. We can also give more comprehensive analysis of customer data and behavior with more data types collected in later stages. At last, we can implement cookie-like system. Of course, that'll require a database system to memorize on-page shopping carts or past customer behavior, et cetera, et cetera. Some of the self-reflection we have done is that we think object-oriented approach can help building the system effectively and modularize the design. And we should always check the feasibility of each component before we do any integration. And of course, communication is definitely pivotal in teamwork. And we should always think more from the view of customer instead of an engineer when we do the design. And last, the security issue should always be taken care at the first priority. This is some of the distribution of labor between me and my group mates. And thank you for listening. That's all.